Great. Nice. Design a fitness trend. Sounds like fun. Yep. Is there any sort of overview you want to give me on this? What do you think?
Hi, Monica. We are going to do another system design mock interview. Today, our topic is Strava. I never used Strava, but it's a similar app, similar like Apple's activity or other activity tracking app.
Yeah, I'm not an Apple user. Can you name another program that a PC user might know or an Android user might know?
Android. For Android, Fitness Meta has a similar competitive product called Fitbit.
This is like
Yeah. So with that, users would be able to create activity with selected activity type. For the simplicity, we would only consider run or bike in this interview. Once they created, they can start, pause, stop, and save their activity. During an activity, users should be able to view their live activity data, such as routes.
Can you summarize instead of telling me all the different features?
Users should be able to view their activity details, and after the activity completed, users should be able to view their own activity and their friends.
Oh, so you can share it with your friends.
Yeah.
And that's really interesting. Okay, I've got it. And do you want to give me any prompts or directives for my note taking during this mock interview?
First of all, always focus on the logic. Am I telling the story so you can understand? And then verb, subject agreements, grammars.
Grammar is infallible.
Yeah. And first, let's see what the non-functional or quality requirements we need to fulfill are. First, we value availability over consistency, which means at any time we want the app to be available for the users, and users would be able to understand if the data have a few seconds delay. And we support activity tracking with low or no network. And we support the activities can activities scale up to 10 million because we allow 10 million daily active user. That to the maximum, we would possibly have 10 million concurrent activities. And users should be view up to date activity details. Users should be able to view their details during in the real time with their own activity.
You still there?
I'm still there.
Do you think it? I can't see you, so.
You can't see me?
Mhm.
Okay, now let's go to core entities. The first one, users, of course, and then their friends, and then activities. No. Not last but not least, their roots. But these could be a features, could be a field activity. APIs. Oh, the first user should be able to create an activity that will be post API call with endpoint with activity type. And once they create an activity, they would be able to update. I would use patch, but a patch would allow the user to date a single activity field. Post would also work here as long as user provide the whole activity details. Activity ID. And we have informations like status, whether the user is pausing, what the user is pausing, redo, or stop the activity. The user would be able to view activities. Get images, and they can view either their own or their friends, and we support pagination. So they pagination. And return a partial collection of activities. And the user would be able to update their root. It would include like informations like their latitude, longitude, time step. T. The field longitude and latitude is GPS coordinates. And timestamp. Okay. Single user's ID. Besides view a list of activities, user would need to view specific activities detail. I'll just copy this to make it faster. It will return an activity and all the root's data. It's root data. Next, how will the user be able to start, pause, stop to an activity? First, the user interacts with their mobile application. We call it our client app. Clients and the client app send a update activity requests with the actions like the start or pause or stop or save to the activity server. The GVT server. And the server interact with the database. And the database have activity table. Once the user create an activity, the activity should contain activity ID, which is the primary key here, and user ID, and type, whether it is a run or jogging or other type of activity, start time, end time, root ID, and event update JSON file. JSON, like when the user pause or resume the data, we would append an event to the event update JSON. And that's the user. The server would return this activity to the user. So I would change the arrow to be double-headed. How can users view live statics from their current activity while running, or view live statistic? We would utilize the utilize the mobile phone's GPS features. These days, the smartphone all support GPS tracking. Ah, here you go. Okay. It's GPS. Once a user starts an activity, the GPS starts to periodically records the longitude, latitude, and the timestamp and send to the server. Which and the recorded time locations can also reflect on user's application. In this case, user would be able to view their live statistics. When in the same time, the client would also periodically sync through live statistics to the database through the application server. So I would add a API call, update, root, include root ID and other informations. ID, altitude, latitude, timestamp. And we would calculate the distance based on the route. Next. For a long bike ride in particular, recalculating the total distance based on routes can be expensive. How can you make it more efficient? Calling the server periodically is an expensive calculation, and especially we always calculate the distance. To avoid this, we can run all of this on the client application. These days, mobile applications are quite powerful. We can add every time when the GPS sends a new coordinate, we save it in memory buffer. And then to avoid this buffer get lost, such as due to app crash or loss of network, we save the activity data into a persistent storage on the phone. And if there is a app crash or something, when the app restart, the app should first request ongoing activity data within the persistent storage. In this way, we eliminate information loss. And to avoid recalculating, we should use incremental approach, which means On every coordinate updates, we calculate the incremental distance with the previous coordinate using geographic formula because the Earth is a sphere, not a flat grid. So we should use geographic formula such as hovering calculation. In this way, we don't need to recalculate the total distance in the end. And when the client stops the activity, we can save the total distance to the server, and the server would update the database. How will users be able to view details about their own and their friends' completed activity? In this case, users send view requests, send a get request to activity endpoint with either the mode equal to user or friends. Whenever a friends relation is created, we save the friends relation bidirectionally so that when we query the friends database, we can quickly find the both side friendship. Whenever a user requests a friends mode, we first query all the friends of this user and then join all the friends activity and return to the client application. First, we filtered activity status equals completed and return to the user. How will your system support tracking activities while user device is offline? As we have mentioned it, we rely on mobile phones, GPS features, and we save activity routes update in memory and also persistent storage. In this way, we avoid relying on the server to track the activity updates. Whenever the user device is back to online, the app can sync the persistent storage on the app to the database. In this way, we wouldn't lose any information. Besides local tracking, we could also do the calculation part on device, like calculating the total distance, like average speed on the device. In this way, we don't need a server to calculate those information. How can we support up-to-date share activities with friends? To support up-to-date activity, the system needs to go back to the periodic sync with the server, as opposed to totally rely on the mobile device. To allow sharing, first, the app periodically sync the data to the database. When it is a run, we can use like 5 seconds. When it's a bike, we can use a shorter time period. And then in the same time, we all the friends application need to start to polling the information to avoid the delays. We can, like, for example, user update the data every 3 or 5 seconds, depends on the activity type, and friends application pull the information with like maybe 1 second delay. This would enable a smooth live sharing, and we also avoid the expensive and complicated WebSocket implication, because in this way we know the time sharing pattern. We do this for all the in-progress activity. Well, how can we expose up-to-date leaderboard with top athletes globally based on the total distance covered? If we need an leaderboard with all the top athletes globally, then we need a data structure that quickly sort all the athletes' performance. In this case, a database, every time we query the database and calculate the score, would be very expensive. To solve the problem, we can rely on a Redis sorted set, which we can use activity ID as the key, and then their total timestamp, total time as the score. Because sorted set, you skip this, which allow all one time complexity level of insertion. So very quick, and return the sorted list to allow letterboard of each country. We can add a key such as activity and colon country. In this way, we would enable country level leaderboard. There is a problem of there's a country of bringing in Redis, that is to synchronization between the main database and the Redis. So we would either use a CDC to write into the database and the Redis. We could also have a time. Yeah, I think that's all. Just need a bi-directional synchronization between the database and the Redis to avoid the inconsistency between the main database and Redis. We're finished.
Wow. Well, that was that's interesting because there's so much real world language in that description as opposed to some of the more technical things that you've explained to me. It was actually a much more challenging subject-verb agreement content.
Do you want to
There's a lot more real world, but you did very well. So when change rooms, we'll come back and look, okay?
And what?